Okay, now we're going to move on from linear functions to quadratic functions. Quadratics are the form of y equals ax squared plus bx plus c. Now, to be a quadratic, a cannot equal 0. In other words, you must have an x squared for it to be quadratic. If a was equal to 0, you've just got a linear function, bx plus c. So a cannot be equal to 0, b or c can equal 0. Alright, so you may have ax squared plus bx, you mightn't have a plus c, so that's still a quadratic. So as long as you've got a term in x squared, it's a quadratic. Now, quadratics, if linear graphs are straight lines, quadratics are parabolas. And let's just do some generalization here. We've got a parabola, looks like that. It's not sort of circular, it's not like half a circle, it's certainly much closer together up here. So it's not like the center of a circle. You don't think of it like being a part of a circle. It's much different to that. So it's sort of like a circle, and then you join these two, come up, don't join them, but you push them up a little bit. So these values here, now the c value is certainly the same, so that's going to be where it cuts the y-axis, because if you put x equals 0 in here, that term will be 0, that term will be 0, so you get y equals c. So that is where it cuts the y-axis. If you go back to your knowledge of the quadratic formula, x equals minus b. Now if we're trying to solve, let's before we do that, if we're trying to find ax squared plus bx plus c equals 0, so in other words, we've made y equals 0. Now y equals 0 is where it's going to cut the x-axis. And we know from our quadratic formula, x equals minus b plus or minus square root b squared minus 4ac all over 2a. Now that's the two values, two possible values that will be the zeros, or when the whole function's equal to 0. So one of these will be the plus. You can't tell just by looking at it which one is going to be this point over here. Minus b, plus or minus, so the plus could be this point, or the minus could be this point, and this point would be the other point. Okay, and the third point, sometimes it's important, this point down here, which is, if you like, the lowest the graph becomes, is the turning point. And incidentally, the x value of that turning point is exactly halfway between the zeros. It is symmetrical graph about, this is what's called an axis of symmetry. And basically, if we could cut this graph out and fold it along that dotted line, this would sit exactly over the top of that. So the distance from there to there is exactly the same as the distance from there to there. But the x value of the turning point is equal to minus b on 2a. Now that's worthwhile remembering, that it will allow us to work out the x value. Now, given that you've got the x value of that turning point, if you put that x value back in for x there, you're going to be able to find out the corresponding y value and get the two coordinates of that point there. So the x value is minus b on 2a. When you've worked out that as a number, put that in for x and you'll find out the y value for that turning point. Alright, so let's have a look at trying to sketch this graph. We know it's going to cut through -3. And then we're going to find the zeros, or find when y equals 0, or let's go when x equals 0. X equals 0, y equals 3. When y equals 0, we've got x squared plus 2x minus 3 equals 0. So we've got a equals 1, b equals 2, c equals negative 3, don't forget to pick up that negative there, x equals minus b plus or minus square root b squared minus 4ac all over 2a equals minus 2 plus or minus square root 2 squared minus 4 times a 1 times negative 3 all over 2. Negative 2 plus or minus, now that's the square root of 4, and that is minus negative 12, so that'll be 4 plus 12 is 16 all over 2 equals negative 2 plus or minus square root of 16 is 4 over 2. So if we take the positive, we've got negative 2 plus 4 on 2, or negative 2 minus 4 on 2, and it will become negative 2 plus 4, which is positive 2 over 2, which is 1, or negative 2 minus 2 is negative 6 over 2, or negative 3. So they are the 2 points where our graph is going to cut the x-axis. So we can start putting this information on our graph. We know that it cuts the y-axis at y equals 3. Is that right? No, y equals negative 3. I missed the negative up here. So when x is equal to 0, you got 0 plus 0 minus 3, so y equals negative 3. So we know it cuts the y-axis down there at negative 3. And when y equals 0, so everywhere along the x-axis, we've got 1 or negative 3. So it's going to cut the x-axis at negative 3 and 1. Okay, we're getting a bit of an idea of what our parabola looks like. We probably need to find the turning point. The turning point, so the x value of the turning point is minus b on 2a. Now b is 2, so that'll be negative 2 over 2, which is equal to negative 1. So that's the x coordinate of the turning point. Now we did say that the axis of symmetry, or the turning point down here, this axis makes the graph, it is symmetrical about the this line of symmetry, and x equals negative 1. It looks exactly halfway between the 2 points where it cuts the x-axis, so negative 3 and positive 1. Minus 1, that's 2 units, and that's 2 units. So yes, that looks correct. Now to work out the y value, we've only got the formula for the x value, but we put that x value back in the equation. So y equals x squared, so negative 1 squared, plus 2x plus 2, negative 1, minus 3. So that's 1 minus 2 minus 3, which is equal to negative 4. So negative 1, negative 4, so that would turn out to be around about here. Let's just put that negative 3, it's getting a bit crowded in here. So let's put negative 3 over there. Oh, negative 3 was up there, wasn't it? So that's my negative 3. And this is negative 4. So negative 1, negative 4 is my turning point, TP, turning point. And it's where the graph, either in this case it reaches the bottom, but we're going to look later on at graphs that go up like that, so it'll be the highest point of the graph. In this case it's the lowest. So negative 1, negative 4 is that point there. So I've got lots of points now, and then it's a matter of just a bit of practice and drawing a nice smooth curve through a parabola through all points. Name your axes, That's my x, that's my y. This is my axis of symmetry. I've actually got the point there, so I don't need to write on there. We know that's x, the equation of that dotted line is x equals -1. We've worked out our turning point of that graph, and that's about it. So quadratics are in the shape of parabolas. We can find out we can certainly find the x-intercepts when the whole function's equal to 0, and we use our quadratic formula to work out our x and x values, the two x values where it cuts the x-axis. The c value, like in other work we've done with linear equations, is just where it cuts the y-axis. And then the turning point, which is in this case the lowest value, the function would have a least value of -4. And we can do that by the x coordinate is -b on 2a. And then when we get that x value, we sub it in the original equation to find out what the y value. If you were asked, just finishing up, what the domain and range is, the domain are all possible x values. Now this looks like it's getting steep, but it actually goes on forever. So the domain will be -infinity, less than x, less than +infinity. And the range are all possible y values. Now the graph never actually comes back down here again. It's certainly the greatest value y can have will be +infinity. But what is the least value? Well, we've isolated the fact that it can't go below y equals -4. So -4 is the least value that the function can take. Can it take -4? Yes, it can. If you put x equals -1 in this equation, you'll actually get -4. So it can take, so we've got to put y is greater than or equal to -4.